Welcome, everyone, and thank you for joining us today for 5 Steps to Assuring Quality of Experience. My name is Raleigh Gould, and I will be your moderator for today's event. Our featured speakers are Enterprise Management Associates, VP of Research, Jim Fry, and Fluke Networks Director of Enterprise Products, Doug Roberts. Jim has over 25 years of experience in the computing industry, developing, deploying, managing, and marketing software and hardware products, with the last 20 of those years spent in network management. Doug has worked in the IT industry for over 18 years in various business development, product management, and innovative roles. Currently oversees the product strategy across enterprise, cloud, and service provider landscapes. And now I'd like to go ahead and turn things over to our first featured speaker, Jim Fry. Jim?
Thank you, Raleigh. Welcome, everyone. Thanks for joining us. We've got what I think is a very interesting and timely topic to talk about today, and that is how we're going to go about handling and managing and understanding quality of experience. So we'll start out with making sure that everyone understands what we're referring to when we talk about QoE. I'll spend a little time talking through that from what EMA sees from a research perspective. And then we'll give Doug a chance to introduce himself and Fluke so we understand his viewpoint as we then jointly go through and talk about 5 steps that we think are going to help you get a better grip on understanding and managing quality of experience. So let's jump right in. So first off, what do we mean by QoE? Now, quality of experience really is a set of measures or metrics that you're trying to come up with they're trying to assess and understand the sort of touch point between technology and the users of technology. In this case, this is mostly internal IT end users. It could also be customers, could be business partners. But essentially, it's that interface point between information technologies and the users of information technologies and how well the IT is serving the needs of those users. So consequently, there's a very human aspect to this. And it gets a little bit dodgy to try to actually put hard numbers on this sometimes because the roots of quality of experience or experience in general is built around individuals' own expectations and needs and perceptions. So while this can be very personal in nature, there is, of course, a set of definitions you can come up with that we'll talk about today that help you, figure out what you can measure, what you can manage. And I think the things I want to point out here is that it's variable. It varies by service and application type. We're going to talk about some of those variations today. Now, I've also said in the middle of this slide here, there are many contributing factors. If you think about the quality of experience, just think about quality of experience that you have with your own laptop or your smartphone. And there's a number of things that come into this. First of all, you're usually accessing some form of application or service. And so the way that application is designed is a factor in your quality of experience. Another big one, and the one we're going to talk a lot about today, is how well the IT infrastructure and the architectures that are put in place to get that application to you, how well they're doing their job. How well, in other words, are you getting the applications delivered to you? And then the last big area of contributing factors has to do with the platform that you're accessing things from. These are the endpoint attributes. Could be a smartphone, could be a tablet, could be a traditional desktop or a laptop, any number of things. So those all contribute to the total calculation of quality of experience. We're going to talk about what to do about each of these factors today. But I also want to spend a little time talking about some really closely related terms and concepts that get thrown around and oftentimes are confused with QoE. First one is end user experience. Now, end user experience is the broader superset of the total experience that end users will have with IT, not just the applications, but the technology, how well it fits in their lives. This is very experiential in nature and really is sort of the superset of the concept of an outside look in from the user perspective. Service quality, on the other hand, also trying to understand interactions, but typically is more of an inside-out viewpoint that says within IT, what kind of services do we want to try to deliver and at what levels of objectives or agreements are we going to structure our objectives for operations. So think of service quality as sort of an inside-out approach to quality, end user experience being the complete outside-in approach, and then QoE is kind of where this meets in the middle. This is the interface point between the internal IT objectives and the external actual experience. The reason I think this is important to define these is that I've done some research recently, and I've not been following QoE as a specific topic, but I do follow interest and importance of things like service quality and end user experience, according to the group that I follow most normally, which is network and infrastructure management folks. So here's some findings we had just a couple months ago. I published a report, and we were checking in on how important these kinds of measures were to the average network operator and networking professional. And the answer is it's pretty important, and in fact, it's becoming more and more important over time. So folks are already recognizing the importance for understanding service quality, for understanding end user experience, and then right behind that, and closely related, by the way, things like application performance. So it's getting a lot of attention. Clearly, a majority of the folks out there have this top of mind in some way, shape, or form. So let's figure out how we can really start, getting down to the belts and braces of how we're going to measure this and really get on the proactive side of this. So why is it important? Important around QoE is this is the experience point. This is where end users access information technology, and therefore this is how well they're going to be able to leverage the IT enablement that you're trying to provide. So technology is meant to enable business processes, really heavily drives productivity improvements and high levels of productivity, has certain levels of expectations attached to it. It really is the how IT is being effective and not just the what of what type of application is it. And I'm mentioning here and including a list here of some things that will go wrong if you don't pay attention to QoE. Certainly, I'm sure pretty much everyone on this session can relate to situations where you're trying to use a website or an application or voice over IP is another great example. We're going to talk about that specifically today, and it's not working right. Basically, it slows you down. You're not going to get your work done as quickly or as efficiently. If it takes a little bit longer than just a short period of time for you to get through whatever you're trying to do, well, then you lose focus. You go do something else. And maybe this is just me, but you might forget to go back and do the thing you were doing. So loss of focus can be a significant problem. This all sort of rolls down to hits to productivity. It means the organization that you're trying to enable with IT and information technologies is not reaping the benefits, the full benefits of that information technology. This can directly result in loss of business, especially when you're talking about interfaces that are supporting customers. And then it also, not directly, it's one of the factors, that can lead to disillusionment with IT and the desire to go outside and do your own thing. In line of business saying, look, let's go build our own infrastructure. So this is the whole shadow IT problem. This is not the only function or the only factor, but it certainly is one of the potential aggravating factors. So how can we measure this? What's the approach to take to say, all right, we understand the importance of QoE. How are we going to go about figuring out what it really is and getting our hands around this? Well, as I mentioned earlier, there's multiple factors that contribute to this. Some of them are within the realm of the IT organization, of the operations team, of infrastructure and network management, and some are not, frankly. So a bunch of them have to do with human factors and the way that the application has been designed. That really is the realm of the app dev team. They're going to have to work on that. By the way, most app dev teams have human factors aspects of their application design. Not all of them do, but many of them do. On the endpoint side, you can, as an IT operations organization, you can measure some things about what's going on with the endpoint, but there's a lot of variables that you can't necessarily directly control as well. But you can understand, generally speaking, what's the health and responsiveness of that endpoint. You can't know exactly what's going on with the mammal on the other side of that endpoint. And so there's some things that you can't really control or measure directly or understand, whether it's just a person getting distracted or talking to somebody instead of responding in a timely manner to a prompt from an application, or if it's actually something that's going on that's slow within their endpoint. So what we can focus on for certain, though, is the delivery part of the equation. How we're going to make sure that we're doing everything possible to optimize not only availability but performance of delivery of applications across the infrastructure. That's where we can get down to some real science-oriented techniques around QoE and what the bulk of our conversation is today. How do you get started? Well, to really manage this, you have to start with measurement. And for measurement in this regard, the number one objective is to make sure you've got visibility. We're going to talk about some details about what you're going to need to do from a visibility perspective. But let me just say this right now. It's important to make sure that you're able to see live activity. Can't be after the fact, because experience doesn't happen in batch chunks. Experience happens on a continuous basis. This is the real-time world of human interaction. Not only that, you need to be in a situation where you've not only have the view into live activity, but you've got a continuous monitoring profile of approach and some way to understand that there is a mix of applications. And you've got to be able to handle what is unique and different about each different type of application and service that is in the mix in your environments. So EMA actually tracks a lot of network management tools and technologies, and we recommend one that's called Application Aware Network Performance Management for this kind of purpose. It's very well fit for this kind of challenge around understanding QoE and the delivery of applications and the success and performance and delivery of applications. So here's some attributes that I think are really helpful. The AANPM type systems are almost always able to help you discern and recognize any type of application you happen to have in the mix. It sees every transaction, and so you're seeing every end user or customer. It sees all the response time components, not only the network flight time, but what's happening on the server end of the equation back in the data center, and also some way to measure or assess what's happening out at the endpoint. You can use these systems to gather direct types of measures. You can also roll up calculated quality metrics. We'll have an example of that in just a second. And ultimately, these kind of platforms can serve multiple purposes that are helpful in understanding not only in what QoE situations are like, but then what you can do about fixing them when something goes wrong. So not only monitoring, but also troubleshooting and planning, and doing planning based on real-world data. So the example I want to put up here, there's a lot of them that we can pull, but I want to walk through the example of voice over IP. I think voice over IP is a great example of something that really is, QoE is very important. As we know, voice over IP's audio, it's a continuous audio type of technology. You have a few quality objectives. Not only do you want to set calls up quickly in a timely manner so people aren't waiting to see if their call goes through, but once it goes through and you connect it up, you want to make sure you have a continuously acceptable level of audio quality. Now, there's a number of things from the delivery perspective that will impact that. A lot of it has to do with network efficiency, things like packet latency and jitter and loss. But echo is another quality measure that comes into play. Now, measuring this and assessing it is something you can do by watching what's happening in the network. You can measure those packet level success metrics. You can roll that up into things like a mean opinion score, which is a general indication of the level of quality of the call. And importantly here, we need to start thinking about voice over IP monitoring as a real-time sort of thing and not just at the end of a call. Traditional tools for voice over IP solutions will generate MOS scores at the end of the call. So that's great if you have a lot of 10-second calls, because you'll have a pretty good sense for what the real effective quality experience was. But as we all know, a lot of calls last longer than that. They can last 10 minutes. They can last 30 minutes. They can last an hour. And you can have 15 or 20 really bad seconds during an hour period of time where the quality really drops and there's major confusion, major loss of efficiency, but then it comes back up okay. And if you're just looking at the call as a whole, well, it's going to look like MOS was just fine. You're going to miss the fact that you had some major problems during the call. So that's why it's important to start thinking about real-time view. And VoIP is a great example of why you need to think in real-time QoE, not just once in a while checking QoE. All right, with that, I would love to hand over to our other speaker, Doug Roberts, and give him a chance to introduce himself and his company so we have the context of knowing that as we go through the 5 steps. Doug?
Great. Thanks, Jim, and good morning, afternoon, evening, depending on where you are in the world. So with that, I'll spend just a couple of minutes here just in terms of brief introduction, and then we'll get straight into the 5 steps related to assuring quality of experience. But just in way of introduction, it's important to note Fluke Networks as a company in terms of who we are and where we come from. I have found more and more in the industry that few people know who Fluke Networks is as a company in relation to our parent company and other companies that we are related to in terms of sister organizations. But point in fact, Fluke Networks is a solely owned subsidiary of the Danaher Corporation. And Danaher, I like to affectionately describe them as one of the largest organizations that you've never heard of before. But in fact, Danaher is an extremely large company. They are considered a holding company, and they currently have 5 strategic segments in which they own specific types and kinds of companies. And one of those strategic segments is what's called the Communications Group. And currently in the Communications Group under Danaher is where you will find Fluke Networks alongside of other brand name companies that I'm certainly sure that several of you on the line are familiar with in terms of Arbor Networks, Tektronix Communications, Fluke Electronics, as well as VSS Monitoring, which is a packet broker and tapping solution company. So it's underneath that Danaher umbrella that we operate as part of the Communications Group as an individual operating company. And you see the relevant size and market-related information related to Fluke Networks. So that's a good brief introduction to who we are as a company. So specifically today, as it relates to products, and we're kind of starting with the end in mind here, that way we can spend the bulk of our time today talking about the subject at hand, and that is all about quality of experience. But as we go through this QOE webinar and we talk about the steps required to take, I think it will be important contextually for you to be able to relate back a type and kind of product that I'm speaking towards whenever I speak about a specific technology approach or a specific feature or function required to achieve that QOE measurement. So specifically today, we're talking about a product called Visual TrueView. Visual TrueView is a little better than a year and a half old in the industry as a new product to the industry. However, it's important to note that Visual TrueView has a long-standing legacy in terms of the technology and the architecture and the underlying makeup that went into creating this product. Specifically, what I mean is Visual TrueView really represents all of the organic development and all of the merger and acquisition activity that Fluke Networks has been involved with over the last 8 years. And it includes, but is not limited to, such acquisitions as ClearSight Networks, Krenog Software, Visual Networks, again, alongside of all of the organic development that we've produced. So far, in the past year and a half, it's been an astounding success as a product specifically tailored to that AANPM type and kind of approach that Jim alluded to earlier. And its key aspects, or I'll use the term claim to fame, so to speak, is the fact that it is simple, it's intelligent, and it's complete. Simple in the fact that it is a plug-and-play approach. It utilizes very advanced auto-discovery and configuration mechanisms to effectively tell you a lot of times what you don't know about your infrastructure today in way of applications, servers, interconnectivity, and the infrastructure as a whole. It's intelligent in the sense that it immediately out of the box begins to start learning what normal activity and behavior is. And that's both in way of utilization and consumption, as well as performance and experience in terms of end user experience. And we'll talk about that as we go along. And it's complete in the fact that this is not just a troubleshooting solution, it's not just a monitoring solution, it's both. It's not just a network-oriented tool, it's not just an application-focused tool, it's both. And it's both by leveraging a myriad of different types and kinds of data sources that we find throughout the infrastructure. And again, we'll speak more to that as we go through, but I briefly wanted to introduce the product that we'll be referring to today. So let's get into it in terms of Fluke Networks and our perspective of this QOE dynamic, as I like to refer to it. So I like to use kind of this timeline or continuum, and you'll notice the specific absence of any dates or years in this case, because honestly the timeline in terms of when and how we progressed to where we are today is really dictated by the industry itself and the types and kinds of organizations that adopted these new technologies as they became available within the industry. But the point in fact is the tagline there is from endpoints to applications. And that's really one of the best ways I've found to describe this migration, if you will, from what we called legacy NPM or legacy network performance management or network performance monitoring solutions. So some 7 to 10 years ago, 90% of the functionality that we found from a troubleshooting or a monitoring perspective as it related specifically to the network could really be classified in the form of things like ping and port connect and availability and device polling and packet capture as a whole, usually in an ad hoc format. But then as the industry progressed, we started to become a little more intelligent as the infrastructure itself became intelligent in terms of we were now able to leverage things like flow-based data. I specifically use the term there, NetFlow, but I use that term flow generically. But then there were other specific technologies made available, such as NBAR, and we also saw the introduction of probes as a fundamental way to acquire data at remote branch sites or distribution areas along the network path. We also saw the introduction of things like expert systems and even, the very beginnings of this concept of quality of service or class of service. And again, as we moved along that time continuum, we eventually saw the introduction of response times, but the origins of response times we really saw in the form of synthetic tests. You can use a specific example like IPSLA, whereby we would take one point in the network and measure against any other point in the network to derive things like just pure network latency or packet loss or jitter or things of that nature. But a lot of times it was still robotically or synthetically derived. And that really led us into, what I call the modern times being defined as the last 2 to 3 years, where the industry really adopted this concept of end user response time. Now, the real big difference between end user response time and that generic term response time was we were now actually measuring based off of real end user activity. So a true HTTP GET or POST or Oracle query or Citrix connection or, SQL call, you name the type and kind of application, we would measure the performance and break down the performance of that real user transaction on the wire as it was occurring. And there's really two fundamental ways you can do that. One is you can just operate at the TCP layer and look at timing parameters between layer 4 activities. The other is you can get really, really smart, really intelligent using things like deep packet inspection to actually measure true end user application transactions, such as the actual executed transaction itself, but that does require a higher order of fidelity or visibility in the form of DPI. So it's really this time continuum between generic response time and end user response time and the rapid adoption of this concept of end user response time that has led to this specific quantifiable area of what we're now calling QoE, or quality of experience. So this time continuum as a whole really represents this migration the industry has taken into this AA-NPM concept, but more specifically into quality of experience as a whole. So enough about that. Let's get straight into the 5 steps.
Okay, thanks, Doug. Thanks for that intro. I think that'll be helpful given understanding the sort of continuum you guys see and the solutions you bring to bear as we talk about these 5 steps. So hopefully you can give some sort of practical examples to the objectives that I'm going to lay out. So there's 5 steps that we have put together here that EMA advocates. Start with establishing visibility. Let me just say a word about assurance. So the term assurance, not everyone is completely familiar with this, but it actually has its roots back in the service provider space. And what it means is bringing together a combination of traditional concepts of availability and performance, and taking a move away from simply reacting to calls to the help desk to trying to be more more measured and more of an engineering type approach to making sure that you're providing and meeting needs and exceeding those needs. So QoE assurance means we're trying to come up with a sequence of steps here that puts you in a more of a control position with respect to understanding and protecting quality of experience. So for step one is make sure you got visibility. This is really important. You can't do much if you don't know what's going on out there. And from a visibility perspective, what EMA recommends is that you need to find techniques that will give you a good combination of both depth and breadth. So from the depth perspective, you need the kind of data sets, the monitoring information that's going to let you see not only the various different types of applications that are out there, because remember there are several of them and they all have their own different sets of expectations around them, but also then can see and provide for you what I was mentioning earlier, this real-time view. So not only can you recognize the continuously changing nature potentially of this QoE, it also puts you in a position to be ready to react when problems occur much more quickly. When you do have to react, you also need enough information to allow you to do triage and troubleshooting as quickly as possible. So it really has to comes down to the depth of the data sources that you choose. The other aspect of this is coverage, topological coverage, the breadth of viewpoint. So you can drop in instrumentation that'll be very deep and only do it in the data center, and that'll tell you a lot, but it's not going to tell you what's going on out at the branch where the end users are. Remember, we're trying to understand what's happening with the human experience, where the mammals are out there, and they're out in the branches typically, or they may be. So not only do you need to cover and put your visibility points close to the central servers, but you also need to put them out where the users are as much as you can. So this means absolutely you need to have some visibility into what's going on in the core network in and around the data center, but also as much as possible out at the remote branch campus sites. And if you can, last point on this one, if you can even get some viewpoint into what's going on out in the access layer, that's helpful too, because you'll see impacts that might have an effect in particular on the delivery part of the equation that you won't be able to see from the core data center perspective. You won't be able to see those other competing activities that might be using up resources that are needed to deliver the applications you want to monitor. So, Doug, with respect to visibility and monitoring viewpoints, what are your thoughts on this?
Yeah, so I'm one of those believers that, a picture speaks 1,000 words. So, I'm going to take kind of a diagram approach to, giving our viewpoint on this. But, let's tackle the topological question first. And, whenever you talk about, depth and breadth of coverage, there's always, fundamental viewpoints in the industry, and you can almost get into religious arguments as to, whether, hardware is the right approach, software is the right approach, leveraging the infrastructure, or, independently monitoring off the wire is the right approach. In fact, all of these questions lead into, our viewpoint being that there's no one magical data source. There's no magical point within the network that is going to provide the necessary visibility in order to cover off on this end-to-end promise that we as vendors, and I speak we as collectively as an industry, have promised to customers. And so with that in mind, this really speaks to the eclectic nature, if you will, by which we collect information from the infrastructure now. And I always tell customers and prospects that, if there's ever a vendor that walks in your door and they tend to bash one data source over another or one particular deployment approach over the other, you need to send them back and show them the door immediately, because, in fact, every single data source, every single deployment approach has its own good and or bad attribute in terms of just administrative overhead versus the value, and the price point, of course, always has to be considered. But in this case, what I'm doing is representing just a simple deployment model where we have a single data center with multiple remote sites and or access points into that data center. And the key here is, first and foremost, location. So the co-location of a device, in this case I'm depicting Visual TrueView. So Visual TrueView within the data center is capable of collecting both raw packet transaction data that's all transpiring and really represents that user to application activity, as well as application to application from a multi-tier perspective activity, all in a single point or a single place. Well, that same appliance can also act as a central collection device or a central repository for both flow collected information, either internal to the data center or external from remote sites, along with being that central point that's doing the polling or collecting that device level health or device level information. So all of this can happen simultaneously within that one collection device. However, to Jim's point about depth and breadth of information from a topological perspective, I've also represented a product that we call TruView Branch, which is nothing more than a lightweight probe that can hang off of a span or go in line at that remote branch location. And a lot of people ask, well, Doug, I'm a little confused. I don't understand. You said that you can poll all the devices at that remote branch from that central TruView server. You said that you could collect flow data from that remote branch without instrumenting anything. That's exactly right. And so there's a certain level of fidelity or data that we can gain without ever touching that remote branch or physically going to that remote branch. However, when you think of things, and again, I agree with Jim and VoIP being an excellent example, if you think of something like voice over IP, while we can certainly collect the QoE information associated with a VoIP call from that branch to a user in or across the data center, what happens if you have a user from branch 1 calling a user in branch 2? Well, in fact, unless we're instrumented at a packet level, at a DPI level, or we're collecting the right information at that branch location, then in effect, all that central server is going to be collecting is the call signaling information that we see associated with the call manager or the call server. So that's a good representation of a point of presence that is required based on supporting this QoE model that we're suggesting. And remember, this is a simple deployment model. If you go to the next slide, it really represents a more advanced deployment model where, hey, life's not that easy. And, I always get chuckles when I put up these stick diagrams. People say, you do know that our infrastructure is much more complex than that. And I do. These are meant to just be examples or representative. But, in fact, we have lots of very large customers that have multiple data centers, certainly more than 2. But the key is you cannot fundamentally break the deployment model regardless of the size and scale of the infrastructure that you're instrumenting. So in this case, where we would have multiple data centers or a very large, very complex network, the exact same deployment model, the exact same collection methodology still holds true. The only difference is you're now distributing your collection devices and then centrally managing them in one point of contact, or that proverbial single pane of glass, which is represented here in terms of TruView Central. So again, the key takeaway here is regardless of whether it's a simple or a more complex network, having the flexibility or the ability to deploy when and where you need that information becomes critical. And it's also important to note that it's not always just hardware. So it's important to note that out there represented at the remote branch, where we have a physical probe visually depicted on the slide, that could just as easily be a software agent that could reside on your router or perhaps your WAN acceleration device, or simply act as a local collection agent sitting or residing within that local subnet. So the flexibility of having both a software versus hardware choice is also a very key or critical component to this topological coverage. Okay. So the next slide is, that's fine. We've covered the topological debate. Now let's talk about the data source, because to me this is the real key critical component to this QoE discussion as a whole. And it really goes back to, why fundamentally we as a company decided to build a product like Visual TruView. Because what we found as you kind of, if you can mentally reference that time continuum I brought up a few slides back, it's important to note that the industry, as they matured over this time period, utilized a lot of these different or individual products. So, some 5 years ago, as recently as, 3 to 5 years ago, and even still today, I walk into organizations and there's a very specific tool that is implemented and used by a very small subset of individuals for doing the polling or the active testing or the availability, and maybe it leverages SNMP or some other form of data source. And then there's usually some sort of packet capturing methodology, whether it's a big old stream to disk box in the data center or it's, remotely deployable, packet capturing agents that can act as on-demand or ad hoc capturing devices. But the key there is these systems still act independently, or they're independent products that are managed and utilized by independent individuals. And the same goes for flow-based solutions, whether that be, NetFlow, SFlow, JFlow, name your flow type, it really doesn't matter. The key, though, is to achieving this QoE mantra that we speak of. It's all about leveraging each and every one of these data sources based on the attributes they provide in context to this quality of the experience. And this is the real difference that we're talking about. This is where the rubber meets the road in terms of a visibility solution and its ability to answer that subjective question of end user experience and or quality of experience. So the ability to take in active test data, flow data, SNMP data, and packet level data and apply that information to a site-based centric model or an application centric model, or maybe even an individual end user troubleshooting model becomes the key critical component. This is no longer about deploying a packet capturing product or a flow collecting product or an availability testing or SNMP product. This is about leveraging those data sources in a fundamentally different way, in a fundamentally different workflow to solve this subjective quality of experience problem. So this is why this is important. So we go to the next slide and let's look at how it actually works in real life. So we talk about, okay, that's great. I have all these different data sources. I'm leveraging them collectively in a singular system. The real reason for this and how it works in real life is this allows you as a user to go into the system, search for any region, any site, any server, any app, any user, any device. So in other words, it now provides a system that works based on how you, and when I say you, I mean you as a troubleshooter, you as an individual tasked with monitoring a piece or portion of the infrastructure is tasked with doing your job. And everyone's different, right? If I work in the DevOps team, I certainly have an application-centric focus. If I work in the network operations team, I'm certainly regionally or site-centric in my approach, or maybe even user-centric. If I work just in the network engineering team, I tend to think in terms of network interfaces and subnets and VLANs and interconnectivity. So you can enter the product based on how you think about your infrastructure and the problem at hand. The key here is that the system itself now takes all of this collected information, regardless or independent of the data source it collected it from, whether it be packets or active test derived, SNMP data, or flow data, and it builds you a contextual model of performance based on that particular parameter. So in this example, I simply typed in site A, and utilizing all these different data sources, the system tells me everything it knows about site A, first and foremost in way of response time or performance and the breakdown of that response time. Secondarily, what is the utilization or the capacity at that particular site? And third, who is doing what? So the proverbial who, what, where, and when at any point in time. So as a user, unless you're the administrator of the box, you don't necessarily know, and quite frankly, it doesn't necessarily matter where this data came from. The key here is that we are putting it together in a context-based model to answer the question at hand, and that is, what is the quality of experience at site A, and if it is poor, why is it poor in terms of the cause and effect approach? So this is really how this works in real life in terms of combined data sources and leveraging these eclectic deployment models.
All right, thanks, Doug. I think that's filled in the questions around depth and breadth pretty well. Number two, let's talk about how you proceed to figure out which applications you're going to focus on. Because as we mentioned before, you have a lot of different applications that are active and different services. You've got to make sure the approach you take can handle anything that you throw at it. Certainly there's a lot of well-known published apps, a lot of web-based apps, but most folks will have, or a lot of shops will have, some unique applications that were developed in-house or for you that tend to be unique to you because it is unique to your business and therefore oftentimes very important for your business and very important to understand QoE around. So you've got to have an approach that lets you not only recognize the mix of applications, but also, though, then be adaptable and extensible to these really important and unique application loads. So that's part one. Part two, just from a practical perspective, the place to focus your QoE efforts initially and to establish some sort of record of success is going to be around those applications and services that have the highest sensitivity and the highest expectations. We've mentioned VoIP a few times, but delivery-sensitive loads, again, we're talking about mostly viewpoints from the infrastructure, so you're going to be trying to understand the delivery situation. Look for those loads that are delivery-sensitive. Unified communications, VoIP, and live video conferencing are great examples here. Very, very sensitive to clean environments and high-priority delivery. Any interruptions, any increase in latency, packet loss, jitter will cause a degradation of quality and therefore a degradation in experience. Another one I'm going to throw out here, which I think is one that's starting to grow in importance and awareness, is a hosted desktop. And in this case, it's not audio that you're transporting back and forth or video images, but it's keystrokes and mouse movements that in some cases, if your users are remote from the servers and you're going across a WAN link, well, you have a very tight latency budget to turn around a keystroke or a mouse movement from a user that's at a remote branch back to the data center where his virtual desktop is hosted, and then get it back out to him to re-render it. So that's a very delivery-sensitive load as well, and something that you will want to pay attention to. And then finally, when you move away from those, just pick out the ones that are most business critical. What are the ones that the IT organization and the line of business you serve care about the most, and prioritize those. Doug, what are your thoughts around this?
Yeah, so I kind of use this diagram or this multi-step diagram to describe this approach because this is more of a systems-based architecture approach. And again, if I use that time continuum we started with, way back in the day, the way we recognized applications a lot of times was based on just simple TCP, UDP port definitions. And I think we're all very aware of, all the problems that can represent in a modern day infrastructure. VoIP and video being certainly a good example where there's any number of thousands of random ports utilized at any point in time to push and pull these video and VoIP streams across the network. So if you think about this in terms of the way you're describing it, Jim, of identifying and then prioritizing applications, it really becomes a multi-tiered proposition. And first and foremost, it's about application recognition. While certainly a standard list of, well-known or TCP, UDP-based port recognition is important, the real key here is utilizing new technology such as DPI. So the ability to go in and distinguish a web from a database, from a streaming video, from a live VoIP application, regardless of port definitions, it becomes a key or a critical component to any solution. And a specific example is, I need the ability to walk into an environment, and I don't care if they're running their mission-critical web service off of TCP port 9687, which would never be detected in any standard, port-based system. I need to be able to recognize that these are, in fact, HTTP calls, and then classify and begin quantifying measurements against that particular application. That's where the DPI recognition comes into. But we actually have a third process that we're becoming big believers in, and that is also leveraging APIs that are accessible and available to us today by way of the infrastructure itself. And what I mean by that specifically is, few infrastructures are there that we walk onto today that don't have, content switches or load balancers or, application acceleration devices that are already preloaded with application definition libraries based on layer 7 definitions. So the ability to tap into these libraries to understand instantly what the application fabric looks like across these infrastructures is a key critical component. So that's about the identification part. The next step is prioritization, and to us, the prioritization really comes into play in terms of the measurement logic that is applied. So whenever you talk about prioritization of, a mission-critical web app, well, this is the ability to instantly start monitoring and baselining and even providing troubleshooting steps for end-user response time measurements. Whereas, again, we keep mentioning VoIP and video, and that's because of the criticality of it, but the ability to do a completely different or an independent measurement, because it is a different type and kind of application that is much more sensitive to the nuances of network, and particularly the transport across the network. So being able to do VoIP and video MOS, as well as marrying or conjoining all of this information with network-associated transport metrics, such as class of service, quality of service, becomes a key critical component. But the last step that I want to kind of exploit here is all of this is for naught. So the ability to walk into any infrastructure and plug and play and instantly understand what the applications look like flowing across the wire, regardless of port definitions, and all of the measurement logic applied, whether it be end user, traditional TCP transaction focused, or VoIP video more real-time measurement focused, is all for naught if the right data presentation and the ability to go in and leverage that data doesn't exist. So the ability to distinguish and clearly depict what this information means in terms of quality of experience becomes a chief or a critical component to this overall proposition. Okay.
Thanks, Doug. Let's move on to step 3. Now, step 3 is now you've got some concept of how you're going to establish visibility, how you're going to pick out and recognize which applications you're going to focus on. Now we want to talk about how we're going to really tune and align what we're going to do from a monitoring perspective to the needs of the organization. And this is where you have to spend a little time talking to those humans that you're trying to understand their experience and their quality of experience. You got to go figure out and work with the organizations. Maybe it's the app dev team. They may have done some of this work. Maybe it's the actual end users themselves, depending on the kind of service it is. Talk to them about the way they use the solutions. Find out what they are looking for in terms of response time. You're not going to be able to help them with their the design of the application necessarily, but when it comes to responsiveness and how long it takes to do certain steps, how long it takes for them to get to applications that they need, you can find out what their expectations are, and you can use that as a basis for setting your own monitoring strategies. So in particular, try to get a handle for a couple of levels of severity of potential problems around QoE, especially with respect to response time. Where does it noticeable? Where does it become productivity impacting? And at what point does it really become useless? Now, there's a big difference between availability and performance here, and that's why I'm trying to talk about this continuum. The key thing here then is recognizing along the way you've got to have a variable. These are variables based on the type of application or the type of user, even groups of users, and in some cases even the time periods at which these activities take place. There may be different sets of expectations and sets of objectives for your QoE monitoring regime. So think about all of these things. The people who will be able to tell you this, or at least give you the input on this, are going to be the organizations that are actually using the applications you're going to monitor. You then have to take that back and decide how you're going to set up monitoring around this. Doug, what are your thoughts in this particular area?
Yeah, I love using this visual slide as a depiction of aligning measurements and alarming and alerting activities to those expectations, because it really starts at that point of expectations. And I've shown this to so many network-centric individuals, and they go, I'd never really thought about that in terms of what other people within my IT organization view the application or the service or the network infrastructure to be. So it's important to first define what is an application, because quite frankly, an application to a network engineer is quite a bit different to what an application means to an IT executive or a systems admin or even an application developer. So the understanding, first and foremost, just to note that, an IT executive views an application as, that overarching thing, if you will, that they've invested millions of dollars in over the last 3 years, and it's still not running properly. They view this very much from a business perspective. Again, where an engineer, views this as a very tangible thing, based on things that operate across the wire in way of conversations and communications. So I'm not going to read through all these definitions, but the key takeaway here is it really depends on who you're talking to as to what an application is. And then if we take this same concept and we convert it to the network, right, and we ask, what is a site? And when we go to the next slide, it's important to understand that, again, it depends on who you're talking to. If I'm talking to an operations group, they view a site many times as a physical location based on a region or a building. If I'm talking to management, a lot of times they view a site as a working group or a business unit, such as finance or HR or accounting. If I'm talking to the WAN manager, they think in very discrete terms of the technology linking these working groups together, specifically devices and interfaces. Where if I'm talking to good old-fashioned engineering, they think in terms of IP routing, right, specifically associated with these working groups, such as subnets and the VLANs and the VRFs that provide all of this interconnectivity. So again, the key takeaway here is depending on who you're talking to will dictate what those infrastructure components mean, and this leads into the baselining and alarming musts for any QoE solution. First, it must provide flexible baselining and alarming options. And this includes, but is not necessarily limited to, floating self-learned baselines, as well as what we call static self-learned baselines. So the ability to self-learn a baseline of what normal behavior is, but then set that line in the sand as a forevermore mark of a threshold breach as to when we alert an alarm. And then finally, something we're all familiar with is forget all of this floating, forget all of this automation. I know good and well what performance should be or what I want to test again. Maybe we are being proactive. I want to measure against an SLA threshold. The second point there being it must support business containers for dashboards and notifications. So this goes back to those previous two slides that I just showed. Again, depending on who you're talking to will dictate what that individual thinks about the infrastructure and how they view what performance or quality of experience means. And so this is a must in order to be able to, include and or exclude the proper components or pieces and parts of the infrastructure in order to build a picture for the individual who is consuming that data. Thirdly, it must provide capabilities to alleviate false positives. And then the key there is to the point possible with anything dealing with user experience. So it is very key that, to understand that, we are dealing with quality of experience, which is subjective by nature. So you have to implement the right processes from a baselining, from a methodology, from a regression analysis perspective, and I won't go any deeper than that, to help alleviate these false positives. And then finally, it must provide for a flexible and extensible notification model. And we're no longer in the world to where just SNMP traps and email messages works. We're in the world of integrating with other higher order systems or providing real-time alerting dashboards or maybe even providing API level connectivity out to third-party systems and or management systems that are dealing with that trouble ticketing processes. So all of these are musts, but again, it all contextually aligns back to who the consumer of this data is.
Thanks, Doug. We're coming up on the top of the hour, so we'll have to get through these last two steps pretty efficiently. Let's talk about number 4. Number 4 is once you've got those first 3 steps in place and you're doing a good job of assessing QoE, keeping an eye on it, there's an opportunity to start moving to a more proactive stance. What this really means is taking advantage of the work you've done in setting up the monitoring, setting up the thresholds, using things like Doug was talking about, baselining, looking for departures from baseline, but then tune everything back just a few steps before things hit critical, and then maybe a few steps before the indicators hit the level where you know that it's noticeable to the end users. This gives you an opportunity to slowly and steadily move towards a position where you're recognizing when situations are getting to a point where they're going to impact productivity, where they're going to become problematic, and actually get a chance to get ahead of some of these things. I know talk to a lot of practitioners who would love to be proactive. They don't feel they have the time, but this is the kind of way you do it. Set up and understand the flow of metrics, the normal behavior, and then take your time but slowly start tuning them towards the proactive opportunities. Doug, a little bit on this, if you can give us your thoughts.
Yeah, exactly. So I call this, threshold to workflow. And really, my viewpoint on what you're talking about here, Jim, is on the threshold side. So we talked about, letting the system create thresholds or, understanding what's normal first. Well, that really leads you into the ability to then leverage that exact same system to become a little more proactive in the sense that you can begin to set your own thresholds in context of what you're measuring against to understand where those barriers for, when the quality of experience seems to be deviated from. But the real key here is in the follow-up slides, and it's in the connection of, if we go to the next slide, the key here is that, you need to be able to set and tune these thresholds in not just a single dimension. So when we talk about quality of experience, this goes back to that kind of holistic or superset conversation we had at the beginning, whereas, it may be a different set of measurements or thresholds that we apply to application performance than it is that we apply to network performance. So, this is representative of application thresholds and performances married to, if we go to the next slide, we're really talking about network performance parameters. They're different parameters. So having a system capable of allowing that tuning and that utilization of thresholds in different contexts remains a key or an imperative part. And then the third and final piece here is it's not just about application or network. You can actually split out subsets of very specific application types, such as VoIP and video, to set very custom thresholds and begin to understand your end user's quality of experience as a whole.
Thanks, Doug. That kind of brings us to the last one, and this is a little bit of motherhood and apple pie, but actually I think the last couple of slides we looked at from your side do a good job of demonstrating this. QoE is something that is a piece of a little bit bigger, broader initiative, a much bigger, broader initiative, which is moving towards more service awareness and service orientation in IT. And actually, frankly, I think it's a real rallying point. Doug talked earlier about the different views of what an application is. Well, everyone can agree, though, that regardless of what their view is, in the end, it has to be used and consumed by a human, and the way that that's going to get measured is in the quality experience that human has. So the opportunity to start sharing the data that you are collecting around QoE is really, really big. It's huge. It can be very powerful. The things you should look for, make sure you got a means for sharing not only the alarms and the problems that you see, but in general the trends and the metrics that you're following. When you reach a point of impact, make sure you're raising an alarm or raising your hand and saying, hey, look, productivity impact happening. I can see it in the QoE metrics. You also have to tune, as we've talked about a few different ways, that information transfer around the various different needs of individual constituencies, because the call center might have a different set of needs around VoIP QoE than the average person at their desk. Finally, there's a growing trend, and we won't have time to talk about this in detail, around shared consoles. And shared consoles, the concept here is interfaces that are used to collect together a number of different operational metrics, and that can be put up in front of large parts of the organization to show the status of the business. And as we get to more businesses that are IT empowered or IT enabled, QoE and IT metrics start to become relevant in those business activity consoles. Doug, we got time for just a couple thoughts on this. What do you think?
Sure. Yeah, it's a single slide, and my definition here is QoE by definition equals different perspectives. And going back to that constituent-based reporting and shared console concept, the key here, or the key takeaway from our perspective, is that having a system that is not single dimension or single threaded in its visibility options is the chief or the critical component here. Because again, we've established the fact that quality of experience is a perspective-based measurement, but also the consumption of that data in terms of what quality experience means to the organization in and of itself is very different across the landscape of users. So having the right dashboard, the right console, the right alarming mechanisms, and the right ability to communicate what this means to the business across the board, regardless of who's consuming it, is the chief or the key takeaway here.
Thanks, Doug. So speaking of key takeaways, let me just wrap up the content part of this webinar with some takeaways hopefully that you will have after joining us today. I think from the UMA perspective, we want to make sure you're recognizing and realizing how important quality of experience is and why, if you're not thinking about this in terms of how you plan your monitoring management strategy, it's time to start thinking about it, because it is going to be one of the ways that you can recognize exactly the job that IT is doing to enable the business. When you go out to do that, find visibility, find techniques that give you both the depth and the breadth of data you're going to need. Make sure that you're working with the actual consumer community, those users that you're trying to measure the QOE around, to understand what their specific needs are. Take advantage of the opportunity once you have this in place to get ahead and be a little more proactive. Then, of course, share the results. With that, thank you very much for joining us. I'm going to hand it back over to Raleigh.
Great. Thank you, Jim. I did want to let the audience know that you can get additional resources from Fluke Networks by visiting the URL on the screen. This will also be part of the resources in the follow-up email that you will receive from EMA tomorrow. Unfortunately, we have run out of time, so we won't have time for Q&A today, but I wanted to thank everyone for joining us and to look out for that email tomorrow. Thanks again, and enjoy the rest of your day.